Hey, go ahead and throw your name on here. It is currently second hour. So all week we have been working on systems of equations. A system of equations is a collection of two or more equations. So a system of inequalities is the same thing, just with inequalities. It is a collection of two or more inequalities. Solutions to a system of inequalities are going to be the points. Mind you, that's plural. It's more than one point now. It's everything greater than or everything less than. The points where both inequalities are true. Okay, so back in 2.8, when we did inequalities, we drew a line shaded above or below. Today, we're going to draw a line shade above or below, and then draw another line shade above or below. The points that are in the double shaded area will be our solutions. Doing things neatly and slowly and lightly today is going to be very helpful. Do not take your pencil and color in so dark that you can't see anything that's happening on your answers or on your graphs. You're not going to be able to see anything that's happening. All right, in our quick write, we discussed those four inequality symbols. We shade above greater than and greater than or equal to. It's a dashed line if it's greater than. It's a solid line if it's greater than or equal to. And if you want to label those, this would be greater. This would be greater or equal. So we shade above, greater than or equal to. And then we shade below less than and less than or equal to. Okay. We still use a dashed line if it's just greater than or just less than. We make it a solid line to signify the or equal to part. Okay, any questions about those? Okay, on your assignment, I put blanks for you to put down the line type and the shading, so you can say solid above, dash below. I did not put that on the notes here, but we can just write it in next to them. So for this first one I've got here for y is less than x, I need to do a dash line and shade below. So you want to write a note to yourself that says dash below, you can. And then for the second one, greater than or equal to, that is a solid above. Okay. Any questions about finding that? Just like what we did in 2.8. Alright, then we can start graphing these ones. So we've got y is less than x. There is an imaginary 1 here as my slope. There's imaginary plus 0 as my y-intercept. So I start my graph at 0. I'm going to graph a slope of 1, so I'm going to go up 1, right 1. I need to go all the way across my graph in both directions. Okay, then I'm going to connect that with a dashed line. And I'm going to give you some hints on shading here in a second, so don't shade yet. Okay. When you shade, shade. Don't color in, just lightly shade it. I would also make my lines go the opposite direction of where the line I graphed is. So I need to shade everything below this. So I'm going to color this way, or shade this way, instead of this way, because it's going to make it a lot easier to see where my line is. So I'm going to come in here, just going to lightly with my pen, your pencil, shade here, okay? You need to shade enough you can tell that it's shaded, but not so much that I can't see through it. I'm going to note sheet, please. Yeah. Okay, then from there, any questions about that first one? Okay, we have to be able to do a whole nother graph on there, so that's why we don't want to shade so dark that we can't see what's underneath it. So now we're going to go graph y is greater than or equal to negative 2x plus 6. So we're going to start at 6. My slope is negative 2. So I'm going to go down to right 1, down to right 1, down to right 1. I need to keep going, so that's, see, I have to be able to see through that so I can see where my points go. And then that one is going to be a solid line. Okay. I'm going to let you guys get that graphed, and then the tricky part is shading the second one. So get that graphed, and then look up, please. Okay. So now we need to shade this second one. I'm going to use my ruler. This is where my line was. I need to shade everything above my line, including the part that's already been shaded once. In order to be able to tell what gets double shaded, you are going to want to shade in the opposite direction of what you've already shaded. So my first shading went this direction. I now want to shade everything above this line in this direction. So everything, including the part that's already been shaded once. Okay. Any questions about that? Okay. Now it makes it easy to see the area of my graph that has been double shaded. So this area over here has not been shaded at all. This space, this little triangle up here, it's been shaded once. This triangle down here, it's been shaded once. It's this section over here that has been double shaded. So this section over here on my graph that has been double shaded is where all of my solutions lie, because they are true for both equations. These are the points that are true for both y is less than x and y is greater than or equal to negative 2x plus 6 at the same time. So then we have an added thing on these ones, because we really want you to understand where your solutions are. So what we've added is some blanks. We are going to have you list out 3 solutions, so 3 points that are solutions and 3 points that are not solutions. Everyone should have different answers on these, because there's an infinite number of points in here that are solutions. So we can pick any point. So I'm going to go over 5 up to that point right there. That is a solution. Okay, what is another point in the double shaded area? So any point over here. 6 over 5 up. Oop, there it is. 6 over 5 up is in the double shaded area. It is a solution. Okay, one more. 5, -4. I agree. Or -2, either one. Both would be correct because there's an infinite number of them. I think I graphed that one wrong. I have like 17 dots over here. Everything that I drew a dot for would be true. Let's put 5, -2. You can put whatever you want. That's a solution. So I think I accidentally graphed 6, -3, and I think I accidentally graphed 6, -4 as well. But 5, -2 is a solution. So any of those points in the double shaded area are not solutions. Or are solutions. Oh my gosh, I just said the completely wrong thing. Okay. Everything else is not a solution. So I could give you a non-solution that's in this area, because it's not a solution, it's only a solution to one, not both. I gave you a non-solution that's in this area. I just stick to the white area because it's just way easier to graph my points. So I'm going to do -2, 2. Let's say -5, 0. Okay, give me one more point. One more non-solution, anyone? Anything? -4, 3. I don't even know if that's what you said, but it works. It's what I heard and it works. -4, 3. Awesome. Okay. Any questions about solutions or non-solutions? Okay, let's get to work on our other one then. So we've got y is greater than 2x plus 4. What type of line should I use for that? Dashed or solid? Dashed, okay. Somebody else, where should I shade that? Y is greater than 2x plus 4. Where should I shade? Above. Awesome. So for that first one, I'm going to do a dashed line and shade above it. So y is greater than 2x plus 4. I'm going to start at 4. My slope is 2, so I'm going to go up 2, right 1. I can also go down 2, left 1. I should, because I want my graphs to go all the way across my coordinate plane. Okay, and then I'm going to do a dashed line. Okay, and I'm going to shade everything above it lightly in one direction. Hey, any questions on that guy? Okay, for my next one, we've got y is less than or equal to -1/3 x minus 4, less than or equal to. I'm going to use a solid line, and I'm going to shade below. So I'm going to start at -4. I'm going to do a slope of -1/3. Down 1, right 3. I'll also go up 1, left 3. To be a solid line on this one. You guys might notice sometimes they cross, your two lines cross at a perfect point. Sometimes they don't. It doesn't matter whether they cross at a perfect point because our solution isn't the one point they cross. It's all the points where the shading is overlapped. Okay, and then I'm shading everything below that. So it's going to be, this is my line, everything below. So this right here will be my double shaded area, and that's my single shaded area. So my solution on this one is everything down in here. This whole bottom left-hand corner. So for solutions, I can do -6, -3, -7, -4. not many of them, but there's plenty. Now let's do -5, -5. Okay, I'm a big fan of working smarter, not harder. And so when I'm able to do these as either, whether it's solutions or non-solutions, I always do them. Super easy non-solutions here. 0, 0, 1, 1, 2, 2. Don't even have to think about which one's X and Y. Okay. Questions right now? Right, one comment I want to make, which is just like a thing that's good to know. It's not going to impact your answers on your assignment. Technically, points that are on a solid line would be solutions. Points that are on a dashed line would not be solutions. So what that means is everything inside this shaded area is a solution. So all of that is a solution. These points that are along this solid line would also be solutions because they're along a solid line. These points that are along this dashed line, not solutions, because this one you have to be less than, or yeah, this one, you would have to be, less than this line, not less than or equal to. On this one, everything in here is a solution. Points along this solid line are also solutions, but points that are along this dashed line are not solutions. I would just avoid picking solutions that are and are not on the, or are on the line. Like, don't make your life harder. But technically, if you wanted to know, the points that are in the double shaded or attached to the double shaded area and on a solid line are solutions. These points over here would not be solutions because they're not attached to the double shaded area. It has to be attached to the double shaded area. All right, I'm going to go ahead and stop this video. Bye, video. Nice knowing you.